To this lecture video. In this video, I am going to explain oscillations and waves and also shock waves. So now let us concentrate on shock waves, which comes under module number 1 of engineering physics prescribed by VTU. So under the topic shock waves, we are going to concentrate on the following points. So here we are going to discuss about Mach number, acoustic wave, ultrasonic wave, subsonic wave and supersonic waves. So these were all the different types of waves discussed here. And first let us concentrate on what is Mach number. Mach number is defined as the ratio of speed of the object in a particular media with respect to the speed of sound in the same media, or Mach number is equal to speed of object divided by speed of sound in the same media. So Mach number is denoted by symbol capital M. So whenever an object speed is equal to the speed of sound, then Mach number will become 1. Whenever the object speed is less than the speed of sound in the same media, the value of Mach number is observed to be less than 1. And at the same time, whenever the speed of the object is greater than that of speed of sound in the same media, then the Mach number m will be greater than 1. So this is what the Mach number. So Mach number is the ratio of speed of object to the speed of sound in the given media. So the Mach number value ranges from, ranges from based upon the speed of object. So if the speed of object is equal to speed of sound, it is 1. If it is less than speed of sound, it is less than 1. If it is greater than the speed of sound, it will be greater than 1. Acoustic waves. Acoustic waves are simply sound waves. So sound waves are moves with a speed of 333 meter per second in air. So sound waves are having frequencies ranges from 20 to 20,000 Hz. Here the amplitude of sound waves or acoustic waves are observed to be very small. So these were all the characteristics of acoustic waves. So acoustic waves are considered as simply a sound wave having velocity 333 meter per second in air, and since the speed of acoustic waves are similar to the speed of sound, the value of m for acoustic waves is observed to be 1. So here the frequencies are ranges from 20 to 20,000 Hz, and the amplitude of vibration or amplitude of the wave is observed to be very small. So these are all the characteristics of acoustic waves. And what are ultrasonic waves? Ultrasonic waves are also considered as pressure waves. Their frequencies are more than 20,000 Hz, and they travels with the same speed of sound. And hence the Mach number of ultrasonic wave is 1. And here ultrasonic waves are similar to that of sound waves, but we cannot hear the sound of ultrasonic waves. And were all considered as pressure waves. And the next type of wave is subsonic wave. If the speed of the mechanical wave or a body moving with certain speed whose speed is less than that of sound, then it is considered as a vehicle moving with subsonic speed, or a wave moving with subsonic speed considered as subsonic wave. All subsonic waves are having Mach number less than 1. And in the picture you can look at a vehicle moves at subsonic speed such that the wave, that is the sound waves produced by it, is overtaking it as shown in picture. Okay. Since the speed of the vehicle is less than the speed of sound, so whatever the sound waves produced by it is moving ahead from it or moving away from it as shown in the picture. and the Mach number of subsonic wave is observed to be less than 1. So that's what the characteristic of subsonic waves. Supersonic waves. Supersonic waves are mechanical waves which travels with speed greater than that of sound. That is, with speed for which Mach number is observed to be greater than 1. A body with supersonic speed zooms ahead by piercing its own sound curtain, leaving behind a series of expanding sound waves with their centers displaced continuously along its trajectory. So that is a type of motion shown in this diagram. So a fighter plane that can fly with supersonic speed. So here the amplitude of supersonic waves are observed to be very large, and the supersonic waves distract the media through which they were all traveling. So these were all some of the characteristics of supersonic waves. So supersonic waves are produced due to sudden dissipation of mechanical energy in a small region. So supersonic waves are having maximum amplitude and they distract the media through which they were all traveling, and the value of Mach number is observed to be greater than 1. And here when we consider a vehicle moves at supersonic speed, the sound waves produced by it is lagging behind when compared to its speed as shown in the picture. So that's what about supersonic waves. And here is a problem. The distance between two pressure sensors in a shock tube is 100 millimeter. The time taken by a shock wave to travel this distance is 200 microseconds. If the velocity of sound under the same condition is 340 meter per second, find the Mach number of the shock wave. So distance between two pressure sensors is given as 100 mm, that is 100 into 10 to the power minus 3 meter, and time taken by the shock wave to travel this distance is 200 microseconds or 200 into 10 to the power minus 6 seconds, and the velocity of sound in the same media is given as 340 meter per second. So first we can able to calculate the velocity of shock wave as x by t, where x is distance travelled and t is the time taken. Further, Mach number m is equal to speed of shock wave divided by speed of sound wave in the same media. Therefore, m is equal to x by at. Substitute the value of x, e and t in the formula. On simplification, the value of m becomes 1.471. So this is what the Mach number associated with the shock wave. Second problem, in a ready shock tube it was observed or found that the time taken to travel between the two sensors is 195 microseconds. If the distance between the two pressure sensors is 100 mm, find the Mach number. So here distance between the sensors is given as 100 mm, and time taken by the shock wave to travel that distance is 195 microseconds. Then the velocity of shock wave is given as x by t, that is 100 into 10 to the power minus 3 by 195 into 10 to the power minus 6. So on simplification, velocity of shock wave is 512.8 meter per second, and further Mach number m is equal to velocity of shock wave by velocity of sound, that is 512.8 divided by a. So here the velocity of sound is not given, therefore Mach number is written as 512.8 by a. If the value of a is given, then it is possible to calculate Mach number. Thank you.